Well, hi, good morning. Thank you for joining me here in my shop. Today is February 9th. Going to be a fourth day on this tube tester. And once again, I'm going to say I'm not terribly hopeful here about success with this because I just, wow, I don't have much experience in dealing with these kinds of machines. There's really not a lot to them. A lot of switches, a lot of wires. Switches and wires. Yeah. So yesterday I changed out the diode that was in it. This is probably just fine, this diode. And the one I put in didn't make any difference in the operation. When I go to do the line adjust function, the meter does not come upscale at all. Mind you, the line adjust function is working, and that can be seen because the pilot light goes up and down in brightness. Okay. The other problem is when I flip it to bias, I think I would have to test this again. I cannot raise the bias voltage very high at all, and nothing else has really been tested at this point. So the way as I understand it now, the way this line thing is working, there's two large transformers in here. One of them has a winding of around, I'm not sure, 5 volts or something like that. And that winding is then used to drive the meter when the switch is in the line position. There's another problem with this unit. Doesn't seem to be functioning right. Perhaps there's something wrong with that transformer and there is no 5 volt voltage there that there should be. Maybe that's the problem. So I think I'm going to try to trace the circuit backwards through here, through the machine. It's not as impossible. Well, let me back up. What makes these machines and anything like it really impossible to trace are the bundles of wires that are in here. Now there's lots of colors on these, so a lot of, this was a kit, come to think of it. This was a kit, and so assumably somebody put this together as a kit, and so they supplied a lot of different colors of wire with this kit. Oh my gosh, look at them all. So what I was going to say is these wires get bundled together, and when they come out the bundle, you can't trace a wire through a bundle. Maybe you can in here. Maybe you can if you have to. So the next really circuit stop on here is let's see, transformer. Then this adjustment, this potentiometer, which is right across the output of the transformer, and then the sliding part, the variable part, is then connected up to the switch, the meter switch, which is set to line right now. And the diode I put in is right here. I'm just making sure it's soldered in. Yeah, there's no doubt about it. So I think since the output of the transformer is put right across this, we should be able to look for the voltage there. Let me turn this right on its face here. So number 9 is this one here. All we have to do really is, let's take a closer look at the situation there. Now I said that this was across this transformer. Oh, so you see what they've done? They've soldered this terminal back to the case, and then the case is grounded like that. Oh well, we may have found the problem already. We may have found it already. That's it? That's the only one? Come on, they have to solder this down to the ground. Oh, here. No. Upside down. Nothing like an automatic focus camera, eh? Come on, camera. There we go. Okay, so the one we're interested in is this one here. Looking for how is the case grounded. It's ridiculous. They tied it back to here, but this is not grounded anywhere. Like that's ridiculous what they did there. Let's look at the tabs now up on top. Well, I can just do it with the camera here. Oh, come on, camera. 8, 9. There's the tabs. Well, I guess there's also the part right on here. This collar might be part of it too. Should we just assume that's a problem and go at it? That's a good question. That'll look good to me. Look at these other ones. They're all doing it. So they've done the same thing here. And here. And over here too. They're all done like that, yet none of these things. Oh my gosh, look at this. It moves. I can actually see I can kind of tell the tab that's sticking through the hole is not touching anything. That's really surprising to me. You would think now what they would do is they take a wire and run through all these, pick up each one of these spots, and then right down to the chassis, nice and solid. Because there's actually no screw attachment. This is just the kind of clipped in thing. I bet you just by moving it, I may have fixed the problem. I may be okay now. I may have established the connection. I can also test this. I can temporarily force a ground onto this and see what happens. Now that sounds like a good idea. So I am going to clip my clip on here. Okay. You can see them all now. All these tabs sticking through here. This kind of almost seems like an engineering oversight, if my story is true. Okay, and having wiggled it, I may have fixed it. Okay, switch is on. It's plugged in. We're set to line. Adjust control. Okay, we're ready. And I got the ground thing here, which I would take and go like this. That's the plan. Here we go. Implement the plan. So we're in line setting. This should have popped up already, but it has not popped up. Okay, we will now apply the ground. And wow, it was really good until I tried it. It's a great sounding idea. That was fantastic. Not the bias, the adjust thing. Let me clip this right onto a chassis spot here. Come on, man. See, the bias goes backwards. It really goes backwards hard. Bias goes backwards. If I don't have a tube in, probably shouldn't matter on the bias. Come back, meter, come back. It's stuck. I think it's stuck. And I don't know how to force it upwards. I saw it pop there. Running this with a low voltage. You know what? Look at this. The voltage is 100. How much you want to bet 100 is down here on this thing? Yeah, maybe I'm just not giving enough juice. There's nothing wrong with it the whole time. And I've just been stupid. That's possible. Yes. When I was working in my career, we supervisors had a policy. Look, it's backwards now. Put this up around 120. And where we said, if stupidity could explain something, look no further for another explanation. Nope. He was there, trying to climb up my leg. Well, we didn't get any meter action here. It's backwards still. How come it's backwards? We're not getting anything happening here at all. Nobody And the meter was in reverse, for crying out loud. For crying out loud. It's on 0 again. Okay, what happens if I go bias? Bias go up, bias goes up. Okay, solved that problem, just me. Bias control not doing much, but then we don't have this thing set up right. What are you doing here, cat? Back on the line. So, bias may be okay. Line's still not working. How come the line is not working? No, you didn't even know I was doing this. Once again, this is Bert. Bert has no white on his back. His brother has a white patch. His brother's name is Wally. Okay, what are you doing here, mister? Yeah, we're really lucky. We got 2 of the nicest cats you could ever have. These 2 guys. Did my black cat hear that? I hope not. Wow. Okay. So this is not coming up even though I've given it time now. There just isn't anything here that I can think of to... See, the problem here with the line adjust is unless you can do the line adjust, you can't know that this thing is calibrated. Of course, with an old tester like this, even with a line adjust. Even with the line adjust, you don't know that it's calibrated all that well. Is there some way around the line adjust? Something that can give me a hint as to when it's correct. Put in a brand new tube, use a line adjust to force the correct GM measurement. That doesn't sound like a very practical way to go. He's back. He's come back. Per machine. Let's test the tube in here. That's what we're going to do. Okay, so the tube tester is set up for 6SA7. Let's switch it on here. There we go. And the line, nothing still. Okay, we're going to throw this to, we'll just leave it like that for now. Plug the tube in. So I have all these controls set already. Everything is right, but the bias is not set. Remember, the bias control is wired backwards, so 0's here and the higher number's over here actually. So we'll set this like that. And the meter on normal. Okay, wish I had a switch for me. I could switch myself to normal. This would be a good time to do the line adjust. We're on the line, still nothing. Okay, we will do the short test. I think this has to be probably in test position. I think you'd have it like this. Short test, so we're watching the short light. Comes on 2. Comes on 7 as it's supposed to. No other shorts reported. We're back to test. Now we set the bias. The bias for this tube is actually 0, so if I can't set it, it's already set. So we'll set this to bias. Okay, we're looking at the meter. We're set on the 10 scale. We'll fool with this control, see what we can do. Like it barely goes up. Like this should throw right over. I should be able to generate 50 volts. I can hardly get a volt off it. But this tube, the test is done at 0 anyway. Luckily. So we can't set the bias. I'm sorry. We can't set the bias. It doesn't seem to be important. Can't set the line. Who knows where it's supposed to be? Here we go. The test. Now, all that's left to do is flip the. We can look at the current flow in the tube. And the meter's not showing that either. Doing something funny there. So the capacitor across the meter, when every time the meter gets a shot, the capacitor charges and then holds it there. And then reversing it like this, I'm worried that in fact it's really pushing much harder than it might look with that capacitor there. We're in the test position, ready for a test. Here we go. It went backwards. That's right, it went backwards. Now I remember. Look at it. Okay. not really okay. Okay, I'm going to stop here, drink a little coffee, then we're going to look at the output of the transformer that I suspect now is maybe the particular output winding that's driving the line meter and all that stuff. Maybe it's gone. It's something's happened to it. Coffee. Okay, away we go. Just in case you can hear kind of a roar in the background of the video, that's just my furnace running. And in case you're wondering, first I'm going to check the ground using ohm meter here. Just like a double check sort of thing. Are these shells really grounded to the chassis? This is the one that yeah, I'd say they're all showing up grounded. Somehow they've managed to do it. Not this one. Oh, this one's different. So I don't know what it is, but why would this one read different? Oh, there we go. Okay, don't know what was happening there. Oh. Well, this must not be on this shell. Okay, I see what's happening here. So this outer surface is a piece of cardboard here. And that's not the shell. This is the shell. Yeah, okay. Okay. And I'm sure all these are going to show up the same way here. 0, 0. Okay, well, my grounding concern is a false concern. Not a concern. Now, the number 9. Let's look on the schematic here. Okay, so the winding is this winding here. And this is the potentiometer right here. That's the one in question. Follow the line. And sorry, I've got an I-bar instead of a pointer up through here and up onto here into the meter selector control. So what I want to do is just read this, and it looks like it's simply between the ground here and the other terminal. That should be easy to do. We saw how the ground was done. They just bend the one terminal down to the chassis or down to the body of the potentiometer. Okay. This is P9. This is P9 here. P9 here. Oh, it's the same thing, isn't it? You know what? P9 here looks pretty much to be the same thing as these ones. Yeah, I misinterpreted this earlier. I thought this P9 was somehow in series with this one. I misinterpreted the diagram. They could have drawn this over here with all the rest of them, but they drew it here for some reason. It got me as to why, but the same thing. The output of this transformer is right across this P9, so same thing's true. So read the top of P9, get the output of this transformer, whatever it's supposed to be. What's it supposed to be? There's no messages here about that. Okay, let's take a look. Okay, I think we're ready. If this test suggests the transformer is the winding's open or something, this whole unit's kind of lost. It's really a shame. So practicing now, there's no power on. All I'm doing is just touching this. This spot is the same as this spot, is the same as this one. You can see the yellow wire just sneaking along. It's all the same. Okay, I've got this set to 60 volts. I imagine it's like 5 volts or something more of that sort. Here we go. Okay, unit's on. Give it the full supply. Okay. Right here. 4 volts. Might be the same here. 4. Why is it not steady? Just my meter reading. 5 volts. Well, that's a suspicious number, isn't it? That sounds like something. That sounds pretty purposeful. That sounds just fine. Okay, so it's 5 volts across this control. So what's coming out on the adjustment of it? 4 whopping volts. That's odd. Oh, so airborne, I'm getting a reading. That's what it is. Watch your fingers there, Jumbo. Put my hand down in here. Yikes. One. Well, it's all over the place. Why would it jump around like that? Okay, so I'm going to grab the adjustment here. We'll take the reading again. This is on the slider or the output. And we're turning it. I wonder if I just need to clean these. Okay, so there's a reading. I turn it and let go. I'm looking for instability here. Turn it and let go. Turn it and let go. Wow, this just seems to be working fine. The range of voltage is coming up. Probably while I'm doing this, the meter is going back and forth normally. Everything's normal. But I can't see the meter now. Okay, so all seems fine at this part. There's not much more to this circuit. There's just some wires now that go up to where that diode is. Let's go up to where the diode is. Let's go up there. Up to the diode. We'll look for the same voltage here. So here's the diode. Here's one side. 0. And here's the other side. Okay, so now I'm going to turn the adjustment. Well, you know, there it is. Whoops. Wait a minute. Always 1.67 no matter what I do. That's weird, eh? Like I turn it, it goes crazy. Oh! No wonder. It's a DC voltage there now. So if we ask it what voltage is appearing on the other side of the diode, we're gonna get kind of a unreliable reading, but it'll show something, a minus 1.8. Now we'll do an adjustment here. Like it likes the 120. And what's going on the other side of this thing? Now this is probably the AC side here. AC reading. Didn't I see something before? Okay, so the meter, I don't know where the switch is set right now. Maybe it's not set on bias, and maybe that affects things. Yeah, well, certainly would affect things. And I'm sure it's not on, did I say bias? Line. I need it switched to line. Okay, let's cut the power. And the switch, where's the switch? Oh man, up you go. Up you go. Make sure it's set on line. Line. Test. Test. Okay. Something about doing this without being able to see the main meter is just kind of absurd. You really should be able to see the meter while doing this. You know what? This thing can be tipped up on its side here. Looks like it might be stable. Let's give it a try. See what happens. Yeah, how do you like that? Okay, that's something. Now, swing it around. What does I want to do? So I want to be able to see the meter, and at the same time, because maybe the meter's working, and at the same time take these readings up in this area. And what else am I doing? What am I doing? Main thing is I want to see the meter. Just 1 second here. Yeah. Okay. Just making sure that's soldered securely. Let's look at the schematic again. In fact, I've got it here in print. Let me just take a look at it in print. So I see the 2 meter leads, meter reversing switch, meter selector switch, diode, resistor. So this wire comes down and reaches adjustment 9. We looked across adjustment 9, found exactly 5 volts. It's pretty suspicious that this thing is generating the 5 volts. We moved the slider and found the voltage varies. When I come up into this area, I'm having trouble now finding these things. It's because the machine was not set to line. I was probably not reading the right terminal on here. We have it set to line now. So all we need to do is observe the meter, and the meter. I'm going to go have a coffee. Okay, so you can see I have a camera aimed right at the switch here, so we can get a closer look at it. And let me pull this guy out of the way here. And maybe this one too, a little bit there. Okay, so it's in the line position right now. Now it's in the bias position, and that's the test position. Now look at how dirty that switch is. But the thing is, if I just move it in between, oop, we can't do it. Yeah, it's dirty, all right. Between the camera bouncing and the tube tester bouncing around here, the camera looks a little shaky, but so put it back in the line position. That's here. This is the line position. Now the 2 contacts that are being picked up, are they moving? Oh, talking, I can't have it shake here. Yeah. I'm looking at the upper one. I think it's moving now. Look at the lower one. Wow. They're moving. They're not moving much. So the idea is I'm sliding the contact underneath the spring-loaded contact, fixed contact, and you should see it go up and down a little bit. Oops. It's rather hard here with this. Not stabilized. What if I can stabilize it like this? That's a little better, but I'm not seeing what I need to see now. Here. I can't do it. I can't see it. So that's the line contact. It doesn't look like it's moving at all to me. Maybe a touch. A much better way to do this would be use the ohm meter and find out this way what it's doing. So what I'll do is I'll put this online. Okay. That should be connecting these 2 terminals. This one and let me check my meter. Okay, should be connecting that one with this one. It's definitely the dirt. What I'm doing now is I'm running this over the dirty part to see if it makes contact. Because sometimes this material is conductive. There's a spot in here that doesn't do it. Oh, I'm on the wrong band. That's why. I gotta be on this side. Yeah. See, it's just really doesn't matter where I contact it. I get a response. So I don't think it's a dirty switch problem. And switch contact seems to be okay according to the test. I only tested one side. Let's test the other side. The other side would be here and then here. Yep. So the switch is making contact appropriately. Now, I've got my oscilloscope running in the background there. And what I'm going to do is I'm going to use the scope. I'm going to get this out of here before I have a little accident. We're going to look at the voltage across the diode only because it's an excuse for me to use my scope. I don't find many times I'm using it. And it might be interesting to see what's going on. I'm not exactly sure what we'd be proving here. So one end is grounded. That's this end, isn't it? Isn't it? Is it? Isn't it? Let's check. Let's do it this way. Ohm meter. Resistance is 0.007 this way, and on the other side, 0. Oh yeah, this is the ground, because I can see the ground. I can see it. I can see it, and I remember yeah, that's right. Okay. I just thought a little harder about it, I would have realized. So, now we're gonna put this, so we can put this like this, and we can put this guy like this. And this will show us what's happening across this diode. The diode. So we'll put this maximum. We're on the AC setting, which is fine. Everything's good. Okay, we're on the line setting. Here we go. Nothing at all happened there. Okay, let me look at the meter. We are on line. The meter is not moving at all, so we got the basic problem in hand here. There's nothing across the diode. So maybe it's a much lower voltage than I have this set. So I've got this on times 10. Let's put it on times 1 and make this less and less sensitive. Oh, that's nothing. That's just noise there. That's as if the am I doing this right? I must be. I mean, this is 20 millivolts now. I mean, this is just hum. This is nothing. I probably turned the unit off and kept the same. How come it's so unstable? And get a better grounding spot. Well, let's use the ground terminal. Wow, there's just nothing there. See, what's going on here? How come it's like, why is it unstable? Is there something going on with that meter at the same time? No. So I just don't understand why it's, I mean, it's just bad contact here. Is it the switch? The switch doing something? Well, that was good. I certainly didn't expect that. Shouldn't we at least see the 60 cycles? We should, shouldn't we? Why wouldn't we see the 60 cycles there? Let me put it back on. Put it back on using the ground terminal here. So we're right across the diode. There's just nothing there. I got the set really sensitive, so we're going to desensitize it. Let me do the adjustment. Adjustment number 9 here. Oh, heavens! What was that? Oh, that buzzing sound was the meter buzzing. Let me stick my head over here and watch what happens when we do this. Right over. Right over. Right over when it. So what I was doing was turning the number 9 adjustment all the way right to a limit, and then suddenly the meter went over. This guy's the problem. But I measured this. The voltage coming out of here was nice and steady, wasn't it? I thought it was. Okay. Well, let's repeat. Rinse and repeat. I'm going to turn this off because I'm just not comfortable swinging it around, this big thing like this. So we want to get on number 9, which is down there. Let's put this on ground. Give me something better. Okay, this outside terminal here is a ground terminal. Okay, and then we want to go on number 9, the adjustment. Number 9, the adjustment. Okay. Okay, so this should just show an EC 60 cycle signal, and I should be able to vary it by turning the control. Okay, I think we're ready. I'm going to put this back. Oh, it's on times 10 now. Okay, times 10. Here we go. Power on. Now that looks like a lovely. So this is the line trigger setting. So you can see it freezes it completely. No question, that's coming from the line. That's coming from that transformer, and this is probably 5 volts. Well, maybe not, because it's on the adjustment. So we're going to adjust it now. When you get it high enough, something starts happening there. The meter goes flying over. The meter goes flying over. Okay, let me stop for a second here and do a little video trick. Okay, here we go again. Now you can see the camera sitting here. It's looking at the meter, and you can see the meter up here. Not very well displayed, but that's a little better. There. I'm now going to make the adjustment. I want to see if the meter comes up a little bit just before it goes all the way. So I'm going down. I want to go up. Ooh, ooh, did you see that? Oh my gosh. Is it just dirt in this control? How can it be? Because this is going up and down nice and smoothly. Let me grab the thing again. Isn't it? And then suddenly it goes wild. Oh my gosh. You see the meter is sticks. Whew. What is this saying? don't know. Yeah. I don't know how to make how do you figure this? How do you figure this? Then the line adjust control is happening ahead of everything because it's a line adjust. So that can't be part of the picture. The picture has to be just this adjustment, the diode, the switch, the meter, wires in between. So we're looking at the potentiometer. We're looking at the output of the potentiometer on the scope. At least I am. You're having some trouble seeing it there. Wow, that's crazy bright. When I adjust the control, the voltage goes up and down, as you would expect. It's going down, 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 down. Now go the other way, it goes up, up, up. Starts going up rapidly at the end. And where's the meter? The meter is nowhere now. It's just, but then suddenly, it's really going up rapidly now. Well, what does that tell you? And then over she goes. Tells me to drink some coffee and look at the schematic and think about these observations. That's what it tells me. I headed off to drink coffee, then I realized, no, look at the schematic, get that in your head, and then go drink some coffee. So what we're finding here is, so there's a resistor right there. And what's that resistor doing? It comes around to these two terminals. So we're bringing up the AC here. The variable AC varied by the control. It's then traveling along and getting onto this wire and heading this way to the reversing switch. Screw, yeah. The other, at that time, the other end is connected here. And it's connected to this wire, which goes over to the reversing switch. So in a sense, all you've done is we've got the hot line coming here. The hot line goes through here, up and around and all reversey stuff. Coming here, driving the meter, now heading back out. Heading back out. Coming down through here and getting back out through this way where it encounters a diode. And that's what rectifies it and gives the meter a single direction. The diode is arranged so the positive end goes to the ground. The positive, is that right? Is that right? I get these things backwards all the time. You'd think after how many years have I been doing this, I would know by now which way this works. Part of my confusion comes from the university I went to, where they use conventional current flow to explain everything. They use electron current flow, and this I never recovered. I never recovered from that, because until I went to college, it was all electron flow in my head. So that generated confusion I never really got over, apparently. So current, what? Electron flow, current flow, which one are you talking about here? So I actually don't know. I think the electron flow is this way, but I'd have to check it. So if that were so, you'd be building up electrons and you'd be building up a positive charge on the negative side of the meter. Well, this can't be backwards on the schematic, and it couldn't be backwards in the machine, and I think it worked at one time and it doesn't work now, so something has happened. What about this crazy capacitor? Could this be doing something? Did I replace this? I have replaced a capacitor like this, but maybe not in this machine. What could this do? It really couldn't do anything. I think I've seen the effects of its dampening effects from it on the meter. So what if, I mean, if this were shorted right out? If this were shorted right out, I think you just get less of the correct operation of the meter. You wouldn't get it reversing. How do you get it to reverse? How do you get it to reverse? Okay, so I had the reverse, that's right, I had the reverse switched reverse. That's how I got the reverse. How do you avoid forgetting everything when you get this old? I don't know. Keep working away at it, I think, is the solution there. Well, there's just nothing coming here. There's nothing coming, so now it's coffee time. So I went and sat down, picked up my coffee cup, immediately got an idea, slammed my coffee cup down, spilled coffee on myself, and came back in here. Okay, so the diode I put in is a silicon diode. The diode that was in there, we don't know about. It's an odd looking guy. Is this a silicon or is this a germanium? So the forward voltage drop on this was up around 9. Is that because it's a bad germanium? So I've gone, I thought, oh, up around 9, it must be a silicon, and maybe it's a little bad because it should be around 0.7. But maybe I have to put a germanium one in there. The forward voltage drop on a germanium is lower. It's about 0.2, a little somewhere in that range. And the forward voltage drop across the germanium diode is higher than a silicon. So maybe what's happening is I'm increasing, like let's say here's the silicon, 0.7. So I'm increasing the voltage, and the meter's not reacting because I'm not crossing the 0.7. As soon as I cross the 0.7, then all hell breaks loose in the machine, and bad things happen. It's because the forward voltage drop is almost nothing beyond the 0.7. So a lot of current can flow. Am I making any sense here? I don't know. But I put a germanium in, and it starts conducting down here. And it has a bit of a voltage drop in it, so it's not all or nothing. As soon as you cross the threshold, it's not, and it doesn't dump everything. So you can fiddle with it. Okay, that's great. Now I'm going to go clean up the coffee mess and drink some of it, and then I'll look at how can we figure this out for sure. Well, where I need certainty. Okay, I realize a mistake I may be making here while I'm investigating things. I'm only feeding this unit with 92 volts. How can I possibly set the line with 92 volts coming in? It will never go up. So let me set the line voltage here to something more proper. I just gotta flip the switch here to do that. See what it is. 109. Let's take it up a little bit higher yet. We'll say 112, 117. Okay, did the meter go up by any chance? Did it go backwards? What did it do there? So I think I've got this still on the line setting, and come to think of it, yeah, it is. There's no way, like the meter should be up. It should have been up. Did it go backwards? Let me drop this. No. You can see the lights going up and down in the unit though. Take it back up to something a little more reasonable, like 110. Okay. We'll adjust the line adjusting again here. You can't see the scope, can you? I can. Okay, so it's looks just beautiful here. And then suddenly something happens at the higher voltage. It's not much of a voltage. There's only one other part involved here. Rotate this carefully. That's this thing. I think it's just a resistor. Okay. Maybe it went open or something? Okay, power off, power off, power off. We'll read that resistor. I'm going to take a peek at the schematic myself. And the schematic shows. Oh, listen, I tried to find out if there was a silicon if it's a silicon or germanium in here. So I looked at the schematic, no information. Look around, no information. Okay, let's ask Mr. Copilot. So I'm just going to read you the response here. Can you help me? This is what I asked. Can you help me find a parts list for my Precise 3 tube tester? And the response is, I couldn't find a specific parts list for the Precise 3 tube tester, but you might find what you need in the Precise 3 tube tester documentation, as they share similarities. I have the documentation, nothing in there. You can check out the Antiques Radio forums for discussions and manuals related to Precise tube testers. Would you like me to search for something more specific? Or do you have any other questions? So I asked the direct question. There's a diode in the line test circuit. I need to know if it's silicon or germanium. And here's its response. Based on the information I found, the diode in the line test circuit of the Precise 3 tube tester is typically a silicon diode. Silicon diodes are commonly used in these types of applications due to their reliability and efficiency. So this is a case where I've got an answer from an AI system. Sounds good, but this is the primary problem with AI systems. They can provide answers that sound really good, but aren't. So even the silicon, this whole idea that it's probably a silicon, that could all be wrong too. Just like any expert, experts are wrong at times. Okay, well, what was that I was going to do? I don't know what I was going to do. I lost track of it. We're going to look at the schematic again. That would be a good idea. These are the instructions you follow the first time you're turning on your newly built tube tester. Now you're working your way down here. Look, plug in the line cord. Okay. Set line adjust control on front panel for a 5-volt AC reading. There's the 5 volts. Without changing any of the above settings, adjust the internal line potentiometer P9. Adjust line adjust control on front panel for 5-volt AC reading. Where? 5 volt where? For 5-volt AC reading. Somewhere up here it says hook up a meter somewhere. Connect an AC meter from ground to terminal 14 of P4. Use a range of at least 10 volts. We got to do this. Connect an AC voltmeter from ground to terminal number 14 of P4. Plug the line cord in. Turn the power switch on. Pilot light should light immediately. If it does not, turn the set off right away because you got some problems. Set the line adjust control on the front panel for a 5-volt AC reading when read to this pin, terminal 14. Without changing any of the above settings, adjust the internal line potentiometer on the for a center scale reading on the tube tester. So what you're doing here is you're controlling the output of that winding at first and using the line adjust to achieve 5 volts. Then when you have 5 volts there, you then make sure the meter is in the middle, because the object is to have 5 volts there. So the meter should be in the middle, and you make this adjustment to get the meter to the middle. And then anytime you adjust the line adjust to the middle, you know you got 5 volts. So it's really a 5-volt reading on this transformer that's going on. It's not really a line adjust. Yeah. Ultimately, yes, but without changing any settings, and a whole bunch more of adjustment stuff to be done. So this little bit here, and this little 14, number 14 of P4. Let's try this out. 14 of PT4. Well, what is that? 14 of PT4. 14 of PT4. What's PT? Power Transformer 4. PT4. This whole thing is PT4. Why don't they call it PT1? This is PT3. Come on, where's 1 and 2? Okay, so PT4. And I forgot the rest of what I was doing. Yeah, I forgot totally what I was doing. Yeah, that happens. I find probably what's happening here is I'm starting to brim. I'm getting too much in my head, too much going at once here. Yeah, that's right. We want to find pin 14 on this. So here, 14's right here. Let's just zoom in a bit, make sure I'm reading this right. 14. So that's this line. That's the input to the adjustment. So you want to make sure this is 5 volts. Well, I measured that and it was pretty close. Close enough. That's not the problem. That's not the problem. So everything's fine here. I turn this control all the way to the limit. Well, one of these limits, probably this way. The voltage increases. We've seen it. And then all of a sudden the meter goes wild. The meter goes wild, everything goes wild at some point. The only thing that can kind of do that is this diode. It's kind of a weird arrangement here, isn't it? No, maybe not. All I'm doing with the diode is trimming off half an AC signal, leaving the other half to go and drive the meter. And this big capacitor smoothing it all out so the meter doesn't shake or vibrate. Oh my gosh, this is the simplest thing in the world. Why won't you work? Why won't you work? I gotta find this capacitor. Maybe there's something weird going on with that. C4 100 microfarads? Picofarads? Did they say anything? All capacitance in microfarads. So it's 100 microfarad. That's a big whopper. That's quite a big capacitor. It should be easy to find it. Okay, let's go looking. Okay, this is off now, and we're looking for. Oh, I got the room effect. I stopped looking at my computer screen and turned here, and my memory just went blank. Ah, okay, hold on my own. I just look back here and remind myself what we're doing. Give the capacitor across the meter, right? So the meter movement is hidden under here. Is the capacitor right on the meter? It is. Oh, Jimmy, you've replaced it. That's not a very reliable capacitor. Oh my gosh, I found the problem. I found the problem. You're looking right at it. Can you see the problem before I get too excited? I think I found the problem. Here, you take a close look. We're going to take an even closer look and see if am I telling the truth? Okay, just hang on here. I'm all excited now. I'm very excited. Let's go and see. Did he find the problem? The thing is, the real problem would be me. Look at. Well, what do you think? You think that's shorted right there? It's pretty lousy looking, isn't it? Unit is off. Oh my gosh! I'll bet you that's all it was. Look at the mark. It looks like a burn mark on the panel. Jim, you knucklehead! Oh my gosh! One of the rules I follow is when I'm working on things and something goes wrong, I'm to blame. That's the first place to go. Who's to blame? I'm to blame. Okay, I'm gonna drink some coffee, then we're gonna try this guy again. See if I didn't find the problem. Oh my gosh. Yeah. Okay. I've been in this place before where I'm quite convinced I have found a problem and solved it, but then in the end, no, it's not the problem. So we will see what happens here. But I'm going to put money down on this. What have I got? What have I got handy here? Let's see. I've got not a lot of money. I've got 2 dead batteries, a coin here from some country. What country is this from? This looks like this is a Japanese coin of some sort. And you probably can't really see it there. And good grief, an American penny. Now, we haven't had pennies in Canada for a long time. Got rid of them a long time ago. There we are. That's what I'm gambling. If this thing doesn't work, somebody gets that. I'll give it to a cat. One of my cats will get that. Okay, so this is on. It's online. The adjustment's in the middle. What's going on underneath, we don't know. We don't care. I flip this on. This meter should go up. Well, not this switch, but this one. Oh, look at it go. Look at it go. Bring it back. Bring it back. Man, it's gone way high. Now, what's happened now is it's stuck up here. This is another, oh no, it's going up higher. Okay, switch off, power off. Well, now it's really working. Yikes. The world's coming to an end. Okay, so I found the problem with the meter. The first problem. Good. We can do a line adjust, except it looks like it's way out of calibration. That's probably because I fooled around with that adjustment. Let's adjust it. Let's do the thing. Let's do the thing. So we want to adjust it. Was 5 volts on the okay, I'm gonna just, I'm too excited here. I gotta slow down a bit. Let me just take a little break here. Okay, let's see how this works out. Close my door there, so if I end up screaming, nobody will hear me. Okay, I'll put this here like that. This has to say 5 volts AC. I'll turn this down. Is that the down way? Oh my gosh, I think it's the down way. Let's put it more in the middle. Who's that? Oh. So much for closing the door. He burst through it. And now he's grabbing my leg. That's what he does. Hello, buddy. Okay, let me know he's here, I guess, is what he's doing. Distractions, distractions. I gotta make mistakes with distractions. So we have this on for the 5. We can't see the meter. I would like to be able to see the meter in case it goes right over. Oh, it's still pinned, isn't it? It's probably still pinned. No, it's back on 0. Okay. So maybe what I can do is I can reduce the input voltage a long ways. I can bring it up slowly. That'll solve all these concerns I have. So put on the what are you doing? I hope you can see him down there. No. He's pretty happy. Concentrate now. 5 volts, but only after I've got like 115 on here. 1 volt. Didn't hear the meter go crazy. The meter's upscale a little wee bit. Very good. Okay, so we want this to be 100. So we want this to come up to 5. We also want this to be 100, and let me look at the meter. The meter is heading for center scale. So I want this to be 5. So first we go 120 here. Actually 115. We'll set it 115. Okay, that's 115 or so, 117 actually. The meter is almost in the middle. 3 volts. So we don't want this to be 3 volts. We want this to be 5. So you see the setting of the. So we're gonna turn this until we get 5. Okay, let me look at the meter. Make sure I'm not pinning it. Nope, it's right in the middle now. Excellent. Excellent. Okay, so we'll go up a little higher. I'm going to grab this and turn the meter down. Oh, wrong way. Oh, it's gone up and gotten stuck. Oh my God, it scared the heck out of me, cat. What a crazy thing. Look, you know, it's a little dangerous up here for you right now. Come with me. Oh my God, I'm caught in the camera. There he goes. He thought that was fun. He wants to do it again. I'm going to lose concentration here. So we're trying to get this to 5 by adjusting the line. Let's worry about that for now. What was the concern anyway? Going the wrong way. Go up, go up, go up. Oh yeah, the meter's pinned, but that's okay in a way, isn't it? No, it isn't. I can't tell what's going on with the meter. We cannot tell. Come down, meter. There. Good. Came down. it's almost dead center. So I'm going to turn this to reduce the meter's position to get it away from the, there we go, away from the sticky spot. Now we'll raise this up to 5. 108 here. We got to go higher. Got to go higher. Can't go higher this way. And dim bulbs are in the circuit. So we're going to go down, go up, and then come back up. 110. Should do this, I think, at 115 or so. Okay, there we are. 115. 5. Come down, 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 down to 5. Okay, so that's the 5. Best you can get it. And now I adjust this to put the meter straight down, and because it's upside down. Uh-oh, what's going on? A little dirt in the control. Oh, a little dirt in the control. There's dirt in this control. That's adding to the trouble. The meter's jumping around. Let me grab this. This might be a little rough. Yeah, and my box here. Okay, you can kind of get. Oh, it's hard for me to. Oh, I see the problem. The problem is I have to kind of. Yeah. Well, here's my best camera angle right here. Right there. Right where? Right there. No. I'm sorry about this, but good enough. You can see where the pointer is supposed to go. Well, now we're just under. So what's happening is the voltage at the house is going up and down, and that's why that meter's moving, I think. So we want that meter to be straight up in the yellow area. You can see. So a little bit of a line adjust here to bring it up to the 5. Ooh, dead on 5. Okay, do the other adjustment. See, this is the one that's. Well, how come it went back down? I'm not doing that. I am doing that. It seems like there's dirt right where it's supposed to be. Right here. Right here. Right here. Right here. There we are. Huh. Excellent. Excellent. And if you look over, you can see 5 volts. Okay, that's enough. That's enough for today. Yes, sirree. Let's get the heck out of here because things are good. That's a good time to stop. Thanks a lot for watching, and tomorrow we'll just continue on, and probably the machine is going to work totally normal from here on in. Fantastic. Found my own fault. It's always my fault. Ask my wife. See ya.